Ready for example 3 in 6.4. This is B as in boy video. The second one will probably end up, well, I know we'll end up into a third, maybe even a fourth. Alright, so let's look at example 3. And in this one we've got two equations. Neither one of them are linear. 2x squared plus 5y squared equals 39. 3x squared minus y squared equals negative 1. Okay, so we're going to use elimination in this one. And gosh, let's see, what are we going to get rid of? I guess probably the easiest thing to get rid of would be the y's, because I can just multiply this by a positive 5, and that'll make this a negative 5, so it'll cancel there. So let's multiply it by negative 5. So when we do that, let me real quickly, okay, we have 2x squared plus 5y squared equals 39. Negative 15x squared minus, oops, gosh, what did I do? That should be a plus 5, not a minus 5. That'll give me minus 5y squared equals negative 5. That makes this a plus 15, doesn't it? Sorry about that. I wasn't thinking as far as getting my negative right here. So I multiply it by a positive 5 so that this stays negative. Alright, now I can add. So I have 17x squared, those go away, equals 34. That's handy. So x squared equals 2, or x equals plus or minus the square root of 2. Don't forget that whole plus or minus part. Okay, so let's get rid of the work here, and we'll put this right there. There's my x value. So I want to keep my original equations here just so I can refer back to them, because I'm going to have to plug my answers in eventually. In fact, right now I'm going to take x equals plus or minus square root of 2 and plug in square root of 2 here. And so I'm going to take just this 3x minus y squared equals negative 1. We're not going to worry about this whole 5 thing in the parentheses. Alright, so now let's put in positive square root of 2. Okay, so this ends up being 3 times, oh, that doesn't look like a very good 2. So 6 minus y squared equals negative 1. So negative y squared equals negative 7, or y squared equals 7. So y equals plus or minus the square root of 7. So when x is a positive square root of 2, y equals plus or minus the square root of 7. Alright, so we'll just hold on to that right now. We'll get to what we do with that in a minute. So that was when we plugged positive square root of 2 in. Alright, now let's get rid of all this, and let's plug in a negative square root of 2, because we're going to do the negative part there. Alright, so we put the negative in, and you do the math, you square this, and you get a positive square root of 2. So basically you end up with y equals plus or minus the square root of 7 again. So when x equals negative square root of 2, y equals plus or minus the square root of 7. Alright, so that is not our answer yet. We're going to take, when x is the square root of 2, what is y? Well, y is going to be plus or minus the square root of 7. So when it's the square root of 2, it's either going to be a positive square root of 7 or a negative square root of 7. When x is negative square root of 2, y is going to be either a positive square root of 7 or a negative square root of 7. Okay, so we've got 4 different places where this is going to cross. Alright, so let's move our answers out of the way here and make a real sloppy graph of what this looks like. So the 2x squared plus 5y squared equals 39, and the 5x squared. Okay, so what we've got here is an ellipse and parabola. Okay, so what we get here is this here from our 2x squared plus 5y squared equals 39. Then we get and a like that. And each one of these points represents one of these. Okay? Crosses at 4 different points, and there's your answer. Okay, so if you've noticed, this is not impossible to do. You're not terrible. You just really, really, really have to keep track of what you're doing. Keep on top of it, because if you make just a slight mistake with a positive or a negative sign, or squaring a square root, or doing that kind of stuff, it's going to really mess things up. So just really pay attention to what you're doing. If I can do it while I'm talking at the same time, you should probably be able to figure it out when you're not talking. Okay, example number 4. We've got an x squared minus, 3y squared equals 6, and we have an xy equals 3. Okay, neither one of them are linear, so we're going to use the substitution method. So let's change that to y equals 3 over x. Okay, that's the one we're going to look at, and we're going to plug it in right there. So we've got x squared minus 3 times 3 over x, the quantity squared, equals 6. Or x squared minus 3 times 9 over x squared equals 6. And just kind of doing one piece at a time. Or x to the 4th minus 27 equals 6x squared. What I did there is multiplied both sides by x squared to get rid of the fraction. And I've got this. Alright, so I'm going to rewrite this as x to the 4th minus 6x squared minus 27 equals 0. Alright. Okay, so notice how I moved everything up. And this right here in yellow is our final answer. And remember, this is old stuff. Take the middle term, and if we make that into a u, then we actually have u squared minus 6u minus 27 equals 0. And we can very easily break this into two binomials. Plus 3 equals 0. So u equals 9, or u equals negative 3. And then we take our substitution and go back. So x equals plus or minus 3, or x equals plus or minus square root of negative 3, which is I square root of 3. So there are my 4 x values. Very important to know that I've got a plus or minus 3 here, and a plus or minus I square root of 3 there. Alright, since y equals 3 over x right there, I'm going to plug in my plus or minus 3 and my plus or minus I square root of 3. So when x is 3, y is 1, right? Because I put a 3 in there. When x is negative 3, my y is negative 1. When my x is I square root of 3, my y is, you're going to have to do the math, that. Okay, because what we get when x is I square root of 3 is 3 over I square root of 3. Can't have a radical or an I in the denominator, so we multiply the top and bottom by what we can't have. And we get 3I square root of 3 over 3I squared. I squared is -1, so that makes that. Cancel that. And we end up with -I square root of 3, which is where we got that. Okay, so just kind of real sloppily explain where that came from. Alright, so when x equals -I square root of 3, my y then equals I square root of 3. Okay, I do the same thing that I did up here with that one, only there's a -I square root of 3. Alright, so what does that give me? It gives me this answer. 3, 1, -3, -1, I square root of 3, -I square root of 3, -I square root of 3, positive I square root of 3. So those are your 4 answers. Alright, so what does this guy look like? Well, I know that it's only going to cross at these 2 points because down here we've got imaginary numbers, so it's not going to cross there. So if we had our graph, we're going to get a graph like that, and then we're going to get another one that looks kind of like that. So it's going to cross at 3, 1 and at -3, 1, but that's it, because these are imaginary. They're not going to cross there. They're still part of the solution set, but there's no intersection there. So that's why you only have 2 points of intersection. Alright, so that's example 4. Let's go to modeling and problem solving, and then we'll jump into nonlinear systems of inequalities, which isn't really too much different than what we just did. I think I'm going to start this on the next video since we're getting close to my 15-minute limit. So we'll see you in 6.4C.